Hi guys, so this lesson is actually 8.5, which I'm going to kind of push into chapter 9, kind of in effort to get a little bit more done so that we have a little bit more time at the end to review overall. So chapter 9 is all about trig functions, okay? So you will eventually learn how to drive and integrate trig functions. So to do that, you kind of have to go back and review trig overall. Okay, so this 8.5 section is just completely review about what you learned last year in pre-calculus with basic trig stuff. Okay, so this first part of this should be completely review for you. We know about SOHCAHTOA. We know that that means that the sine of the angle is equal to the opposite over the hypotenuse. The cosine is adjacent over hypotenuse, and the tangent is opposite over adjacent. I expect that you guys would have that memorized. And we know the three reciprocal functions. Okay, so the reciprocal of sine is cosecant, the reciprocal of cosine is secant, and the reciprocal of tangent is cotangent. Okay, so you could write more information here, but I think that this is kind of narrowing it down very simply for us to do our review. Okay, so for example 1, they draw this right triangle, they give us all three sides, which is very nice, and they ask you to find the ratios. Okay, so it says use the triangle at the right to find these. Okay, so we are writing ratios. Okay, so sine is going to be off of this angle. Okay, so sine is opposite over hypotenuse. So this is simply going to be 4/5. Okay, the cosine is going to be the adjacent over hypotenuse. That will be simply 3/5. We always want to check to see if our fraction can reduce, and in this case it can't. The tangent is going to be the opposites over the adjacent, so that one's going to be 4/3. Okay, the last one here is secant, which we remember is the reciprocal of cosine. So you can do this one of two ways. You can think of this as it's the reciprocal of this ratio here, which would be hypotenuse over adjacent. So hypotenuse over adjacent. Or you can think of it even simpler, that's not a word, but easier, and just reciprocate this fraction here. So we can call that 5/3. Okay, so both ways would get you the same ratio. Okay, so that should be review for you, nothing new there. Okay, so moving down, this is now getting a little bit more onto the idea of putting trig functions onto a coordinate plane. Okay, so this kind of explains a little bit of things right here. So, kind of think of the unit circle. We did this before, and you're drawing your angles. Okay, so your vertex, this is your vertex right here. It's always at the origin. The initial side is this first side right here. So this is your initial side. Okay, and where we end up is your terminal side. So this is your, sorry, that was not straight, terminal side. Okay, and it's important that you realize that we go counterclockwise and go upward. So this is some angle that exists in the second quadrant. You know if it's existing in the second quadrant, what kind of value is your x. If it's going to the left, it would be some negative x value, the y would be positive. Okay, so it's important for you to realize which quadrant has positive and negative values. This goes into talking about using radian measures. Okay, so you know what a radian measure is, that 2 pi is equivalent to 360 degrees. And we're basically going to go back and refresh these ideas. Okay, so this is not some fancy footwork where they just magically decided that sine is going to be, oh, let's choose y over r. Okay, this makes sense in terms of your triangle. So if we go back at this triangle, you can see if I use green, Okay, we're now using this as our angle for the inside. Okay, so if you think about SOHCAHTOA, you say, oh, well, sine is opposite over a hypotenuse, so that's y over r. Okay, so this is basically taking that SOHCAHTOA piece and converting it into the coordinate grid idea. Okay, one thing you have to remember is the r, which is representing the radius, will always be a positive value. Okay, so the only things that can be negative are going to be your x's and y's. Okay, so this piece is important for you. Okay, it's just Pythagorean's theorem. If you prefer to think of this as r squared is equal to x squared plus y squared, then think of it that way. Other than that, we're basically doing exactly the same thing that we did with SOHCAHTOA, but now using a coordinate grid. Okay, so you might want to write those down again, or maybe you already have those memorized. I hope that would be nice. Okay, so for example 2 here, they give us a ordered pair. Okay, so if they're giving us an ordered pair, what two variables are they giving to us? Okay, they're giving us an x value of -5 and a y value of 2. So which variable am I missing? Okay, well, I'm missing my r. So we just said that r was equal to the square root of the x squared, so -5 squared plus the y squared. So that's going to give us 25 minus 4, which gives us our radius of the square root of 21. Okay, and if you could break that, you would absolutely break it, but you can't. Okay, so now it's asking us to find just these 3 trig ratios. Okay, so if I'm thinking about sine, if I look up above, I would say sine is y over r. So I just plug that straight in. My y is 2, my r is the square root of 21. Oops. Okay, which I can't leave. I would reduce that and say that's the 2 square roots of 21 over 21. Okay, if I did cosecant. Cosecant is basically the reciprocal of sine. So I could flip that, but it's going to be easier to flip the unreduced version and do the square root of 21 over 2. That's going to be easier. Okay, the last one is cotangent. Cotangent is x over y, so x over y, so we're going to have -5 over 2. Okay, so hopefully that jogs your memory brain. Moving down here, they talk about reference angles. Okay, so the idea of a reference angle is basically a reference angle is an angle that helps you kind of draw something that's big, like let's just say 200 degrees. But a reference angle will exist between 0 and 90. Okay, so let's talk about these ratios, the 30, 60, 90, and the 45, 45, 90. Okay, so there's a couple different ways to think about this. I am going to start by just drawing it in terms of x's. So I'm going to start with the 30, 60, 90. Okay, so this angle would be 60. This is my smaller one, 30. Okay, so if I'm looking at my short side, which is this, and I call that x, the relationship between the short side and the hypotenuse will always be 2 times bigger. Okay, so 2x. And the relationship to the long side will be x square roots of 3. Okay, so what we can do is we can kind of say, all right, well, I'm going to let my x value be something. So what's a really easy number that we can put in for x and use numbers rather than variables? Okay, so let's say we choose 1. That's really easy. So that means my hypotenuse would be 2. Let me throw in these degrees. And my long leg would be 1 square roots of 3, which is the square root of 3. Okay, so that ratio is going to work for any 30, 60, 90 triangle. Okay, if you think about the 45-45, okay, you know something about the two angles, which tells you something about the two sides. The two sides will be the same, and the relationship to the hypotenuse will be x square roots of 2. Okay, so again, if we go down and give a value to the x, let's choose something very simple such as 1. We'll let the two sides equal 1, so therefore the hypotenuse will be the square root of 2. Okay, so what we're going to do is we're going to use this ratio for the problems down below. Okay. So the first thing that this says is it asks us to draw the angle in standard position and to make a reference triangle. So let's do a standard position. So I'm going to do it off of this initial side, okay, and go around. Okay, so I know that up here this is 90 degrees, this would be 180 degrees, this would be 270, and this would be 360 degrees. So I know that this angle is going to lie over here in this third quadrant, but like how far? So the way I want to think of this is that like how far up from 80 degrees is 210? Okay, so if you did 210 minus 180, you get 30. Okay, so this would be a 30 angle right here. Okay, so what's happening now is I'm creating this little triangle. Okay, so that's what I mean by a reference triangle. So it's just going to be a triangle that's going to be created off of the x-axis. Okay, so and find the cosine. Okay, so the cosine, so again, if we use our little ratios that I had up here before, so I have a 30, 60, 90. Okay, so remember the short leg is 1, the hypotenuse is 2, and the long leg is the square root of 3. Okay, so if I give those values to the triangle I just created, my short leg is 1, my hypotenuse is 2, my long leg is the square root of 3. Okay, but now think of this on a coordinate grid. This x value has to be negative because we're going to the left. Okay, what about the y value? Also has to be negative. Okay, so I can now think of my x value is a negative square root of 3, my y value is negative 1, my r value is 2, and if I do a cosine for that, cosine is x over r, my ratio will be, let's just write this over here, a negative square root of 3 over 2. Okay, so that's all you're doing there. Okay, let's do B. Okay, so now we have 315 degrees. Okay, so 315 degrees. So again, we got this is 90, this is 180, this is 270, 360. So we're getting close to this. If we're going to 315, it's going to be how many degrees off of that? Okay, well if you do 360 minus 315, what do you get? 45. So this angle right here is a 45-degree angle. So that's your reference angle that allows us to draw the reference triangle. Okay, so at this point again I go back to my little 45 this time. Okay, so I said the two short legs are 1 and the hypotenuse is the square root of 2. So I'm going to say this is 1, that's 1, and this is a square root of 2. Okay, so then I think about, okay, on a coordinate grid, my x value goes to the right, so that's going to be a positive 1, but my y value goes down, that's going to be negative. Okay, so now my triangle is all mapped out. Now I can do the tangent ratio, and tangent by definition is y over the x, so I would just have negative 1 over a positive 1, which gives you negative 1. Alright, so moving down here, it says since 2 pi radians is equivalent to 360 degrees, it follows that pi radians is equal to 180 degrees. Okay, for the following common radian measures, convert these into radians or degrees or whatever it is. Okay, so these are radians. Okay, so basically what I'm going to do is I'm going to convert it, which is going to be multiplying by this ratio. Okay, so I'm using this ratio. Okay, so if I have pi over 2, I'm going to multiply by 180 over pi. Okay, so I'm given a radian, so I want to convert it. I want to get rid of the pi, so they're going to cancel out. And we basically have 180 divided by 2, which makes 90 degrees. Okay, so we're just converting between the two forms of measure. Okay, so for b, we have pi over 4. Again, we're going to multiply by 180 over pi. We can cancel that out. And 180 divided by 4 is 45 degrees. And hopefully you can even remember that pi over 4 is 45 degrees. But if you can't, we can keep going with this. Maybe you even remember what pi over 3 is. Okay, and the correct answer would be 60 degrees. Pi over 6 times 180 over pi would create 30 degrees. Okay, so those are angles that you should remember that correlation. Okay, if you have to do the conversion, that's fine, but hopefully you'll save yourself some time in just remembering those. Okay, so if I go the other way, this time we're in radians, and I'm going to convert to degrees, so what ratio will I multiply by? Okay, it'll be the reciprocal of what I did before. Oh, whoops, not on this one. This one is radians, excuse me. So no change here. Okay, so if I cancel that out, I would have, let's see, this would be 225 degrees, 270, so this is where I would multiply by the reciprocal, excuse me. So you can think of this as over 1 times pi over 180. So the way you can think of this is if you were going to type this in the calculator, with the pi kind of off to the side and reduce that, that turns into 3 halves, so it would be 3 pi over 2. And for negative 120, pi over 180. So if I think of it as negative 120 over 180 and reduce that fraction, reduce by 6, so it would be negative 2 pi over 3. Okay. I think we're good to go there. Okay, so this one says to draw the angles in standard position, make the little reference triangle, and then find the following without using a calculator. Okay, here we go. Okay, so 5 pi over 6. Okay, so basically what I want to do is I want to think about how I would get to 5 pi over 6. Okay, so if we convert this into radians instead of degrees, we would have 90 degrees is pi over 2, 180 is pi, this would be 3 pi over 2, and this is 2 pi. Okay, so this is going to kind of require a little remembering from last year with how we created the unit circle. Basically, if I'm going to draw this angle, the idea is that I take my pi and cut it into sixths. Okay, I get that from the denominator. So if I cut my pi into sixths, this would be cutting it into halves, and then I can cut this half into thirds, and this half into thirds, And so now I have 6 sections. So I have 1, 6, 2, 6, 3, 6, which by the way, 3, 6 makes 1 half. 4, 6, 5, 6. So this is my 5 pi over 6 mark right here. So let me change the color here. Wow, that's not straight. Okay, so here is my reference triangle. Okay, what is the angle that's right in here? Okay, so you can think of it in terms now of more like degrees. Okay, so that's going to be your 30, 60, 90 triangle. This is going to be a 30-degree angle. Okay, so if I go back and use my little triangle that I drew before, the short side was 1, my hypotenuse was 2, my long leg is the square root of 3. Okay, so again, if I'm thinking about my coordinate grid, my x value is going to be a negative because I'm going to the left. My y value will be positive. My r is just going to be 2. Okay, so for my tangent, I'm going to do my excuse me, y over x. So that would be 1 over the square root of 3. Which you would reduce and say that's the square root of 3 over 3. Okay. So that's how you do this when they ask you to draw reference triangles. Okay, if I do cosine of negative pi over 4, now that means that I have to go downward and go clockwise. Okay, so now if I'm going to cut my bottom half into fourths, there's halves. Now we're looking at fourths, so now I'm going to count out 3 of them. So I got 1/4, 2/4, 3/4. So this is negative 3 pi over 4. Okay, and fourths is cutting things into 45-degree triangles. So this is a 45. Okay, so the short legs are the same, so they're both going to be 1s. The hypotenuse is the square root of 2. Okay, now if I think of this in terms of the unit circle, my x is going to be a negative. My y is also negative. Okay, so cosine, by definition, is x over r. So that would be negative 1 over the square root of 2, which can be reduced to a negative square root of 2 over 2. Okay, the last one here, let's go back to blue. Okay, we're again going to cut into thirds. Okay, so I'm cutting my pi into thirds. So this one's going to look a little different. We're going to have 1/3, 2/3. No, there's just 3/3. And what you notice is that the top is bigger, so that means that I have to keep going around the circle. So I got 1/3, 2/3, 3/3, 4/3, 5/3. So this one right here is your 5/3. Okay, so 5/3, that's going to be a 30, 60, 90 triangle. Okay, so this angle is a 60 degree. Okay, so using my ratios again, my short leg is 1, my hypotenuse is 2, my long leg is the square root of 3. Okay, if I think about my ordered pairs, my x would be positive because I'm going to the right. My y would be negative because I have to go down. My r is a 2. Okay, so cosecant, which is the reciprocal of sine, is going to be r over y. So in this case I have 2 over a negative square root of 3. So if I simplify that, that becomes negative 2 square root of 3 over 3. Okay, alright, so moving on here, we now get to take this idea to the unit circle, okay, which I think maybe some of you guys are like, man, why can't we just use a unit circle? Well, that's fine. Okay, so what I did here on your OneNote is at the very top I inputted a unit circle for you. Okay, so you might consider printing that out. That's up to you, or maybe you have one already that you saved. Sorry about this is random stuff over here. Okay, so there's our unit circle that you can pull up as we go through this. Okay, so where was I? Here we are. Okay, so I'm now going to just use the unit circle to do these ratios. Okay, I kind of wish I had one right here, but hopefully you pulled it up and you're looking at one as you watch this video. Okay, so we're going to start with the pi over 6. Okay, so pi over 6 is this first one, and we're going to use the unit circle, and since we are using a unit circle, that tells us that the r value is 1. Okay, so we can simplify all of those ratios that we had before and say that now sine is just going to be y, cosine is x, and tangent is y over x. Okay, so that makes things a little bit less complicated, and we can just go straight into using our ordered pairs off of the unit circle. Okay, so if I go to pi over 6, my sine is the y value, so I'm just going to use the ratio there. So it's just 1/2. Hopefully this will keep my spot. There we go. So I got 1/2 here. Okay, sine of 0, if I go to 0 degrees, that's here. My y value is 0, so I can put 0 in there. The x value at 0 degrees, that's 1. Okay, now we're moving on to pi over 2. So at pi over 2, that's going to be straight up. The sine is the y value, so that's 1. The cosine was 0. Okay, now moving to pi. Pi, and it was, what was it? Sorry, sine. I think it was sine. Sine, yep, sine. So sine is y, so we're looking at 0. Tangent was y over x, so if you're looking at, it was -1, 0, it would be 0 over -1, which is 0. Okay, at 3 pi over 2, that's going to be straight down. The sine is -1. Cosine was x, that was 0. Okay, the cosine at negative pi, so negative pi would be this way, but it lands at the exact same spot, so we're looking at cosine being x is -1. Okay, and tangent at negative pi over 2, so that's going to be, instead of going up to here, we're going to go down, so we're looking at this one. Tangent is y over the x, so I have -1 over 0. And you cannot divide by 0, so that's a no solution, undefined value. Okay, so if you were confused about what I just did, then I will attach a link for a video on how to understand the unit circle onto this OneNote, so I'll put it onto the Nolte one. I have too many 1-3 files, I'll fix that, so that you have a link. Okay. Alright, so moving on. So now, as you can see from example 9, the unit circle is particularly useful with finding trig ratios for the quadrants vectors. So then you don't have to use your reference angles. Okay, so that's very nice. I definitely like that. And sine and cosine are the two most important trig functions. As I read that, it like cleared out. It's like, this is how important this is. So the other trig functions can be built into ratios so that you can change them into sine and cosine. Okay, so you've seen this before when we did trig identities. Okay, this one and this one are quotient identities. Okay, so tangent, remember this. Tangent is sine over cosine, which is kind of like y over x if you think about the unit circle. Interesting. Cotangent is cosine over sine. It is the reciprocal of tangent. We knew that already. Okay, and then same thing with these two. They're reciprocals, so we can convert those into sines and cosines. Okay. Alright, so how do I do this one if I'm given a ratio of 3/5? Okay, it says find possible values. Okay, so I know for a fact that sine is y over x. Okay, so if the y, or excuse me, not y over x, y over r. So we have, that's equal to 3/5, so we know that the y value is 3 and the r value is 5. Okay, so we're going back to x, y's, and r's because you can see the r is not 1 any longer, so we're not using the unit circle. So what's the variable that we're missing? Okay, so we're missing x. So you can do a Pythagorean theorem, or hopefully you're noticing this is a 3-4-5 ratio. Does anybody else see that? Okay. But what I don't know about this 4 is if it's a positive or a negative value. It doesn't give us any additional information to tell us that. So I have to say that this could possibly be positive or it could be possibly negative. I don't know for sure. Okay. So now if I do my ratio for cosecant, cosecant is the reciprocal of sine. That one's pretty simple. There's no other possibility than 5/3. For cosine, cosine is the x over the r. So the possibility for this one is it could be 4/5 or it could be a negative 4/5. So you could write that as plus or minus 4/5, but just so you can understand what I'm saying there. Okay, and then tangent is y over x. So this one's going to be plus or minus 3/4. Okay, so now solving trig equations requires you to work backwards. We're covering a lot of trig in this section. Okay, so what you're going to want for this is now to get your unit circle, because we're going to work backwards and we're trying to figure out and solve. We are solving for our angle. Okay, notice we are looking for an angle. Angle. Okay. Okay, so the first thing that I'm going to do is I am going to convert it into either a sine or cosine if that's possible. We can work with tangent and cotangents because those are x over y's, but we're going to use the unit circle to kind of think about this. Okay, so the reciprocal of cosecant is sine, so I can say that this ratio is the same as the sine of x is equal to negative square roots of 3 over 2. Okay. So now what I'm thinking about is, on the unit circle, where are the angles where the sine, because it's a y, is a negative square root of 3 over 2. Okay, so if I go to my unit circle, and now I'm looking for the y value to be a negative square root of 3 over 2, I see 4 pi over 3, and I see 5 pi over 3. So those are my two solutions. Oops. Okay, so my angle is 4 pi over 3, or 5 pi over 3. Okay, so they give you this interval here, meaning you can only use one revolution around the circle. Okay, now this one is one of those cases where it's been reduced. So this is a tangent and a cotangent scenario, so this is one you want to pay close attention to. Okay, so you remember that cotangent is x over y. So then that means that this has been reduced and we have a square root of 3 over 1. Okay, well we can't just say, oh well the x is going to be the square root of 3 and the y is 1, because if you look at the unit circle, do you see anything like that? There's not just a square root of 3 and there's not just a 1. But what I do see is I see a square root of 3 over 2 and a 1/2. And if you look around the circle, they're all grouped that way. Okay, so I know which kind of ordered pair I'm looking at. Okay, so this is what I'm going to do. I would write this down somewhere on your cheat sheet, somewhere very important. Okay, so you have two scenarios here. We know that it's either going to be 1/2 and the square root of 3 over 2, or it's going to be the square root of 3 over 2. And, okay, so if we have to go x over y, x over y. If I do this, I have the x is 1/2, and my y is the square root of 3 over 2. Now if I divide by a fraction, that's the same as multiplying by the reciprocal. So that's the same as multiplying by 2 over the square root of 3. So what happens is the 2's cancel, and that's why you don't see a 2 in this. They have been canceled out. So this gives me 1 over the square root of 3, which can be reduced into the square root of 3 over 3. So is that the ratio that I got? No, it is not the same. So let's look at this one. Let's do a y over the x. Okay, so we're going to have, or excuse me, x over y. So we're going to have a square root of 3 divided by 1/2, which is the same as multiplying by 2 over 1. The 2's cancel, and I have a square root of 3. Okay, so this has reduced to exactly what I have here. Okay, so for this cotangent to equal the square root of 3, we had an ordered pair where the x value was a square root of 3 over 2 and the y value was 1/2. So what was the angle where the x is a square root of 3 and a y was 1/2? Okay, so if we look, it would be at pi over 6. Okay, so pi over 6 is one of the answers. Okay, think about how else we could turn something like this into a positive square root of 3. What happens if they were both negative? If they were both negative, they would cancel out and still turn to a positive. Okay, so we have a second ordered pair that would still reduce into a positive square root of 3. So we can also look at a negative square root of 3 over 2 and a negative 1/2, which is 7 pi over 6. Okay, so this scenario, when you have to deal with cotangents and tangents, that will always be the hardest angle to find because it's been reduced. Okay, so definitely understand, you've got to understand this thinking. Okay, so now on C, we're going a little further. We're solving this trig equation. We have to start by isolating the trig function. Okay, so I would solve this like I would any algebraic equation for the cosine. I would start by adding 1 and dividing by 2. Okay, and then how would you get rid of a square? You square root it. Hopefully you understand this notation. That's not new to you. I didn't talk about it. This is correct notation. If you are using it in the calculator, it looks like this. This is the calculator notation, by the way. Okay, so square root this. So I have the cosine. We have the square root of 1 is 1 over the square root of 2. Okay, which I can simplify. So the cosine is the square root of 2 over 2. Now what did I forget? Solved an equation, I took a square root, I need plus or minus. Okay, so now I grab my unit circle. I'm thinking about the cosine, so I'm looking for x values that are either a positive or a negative square root of 2 over 2. Okay, there are 4 spots. So the x value is the square root of 2 at pi over 4. We're looking at 3 pi over 4, 5 pi over 4, and 7 pi over 4. So 4 answers to this. So my angle is pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. Okay, signs. Oh look, plus or minus. We noticed it. All right. So for this assignment, hold on, I'm going to look through this. Okay, so what I'm going to have you do is I'm going to have you do this whole assignment, 1 through 24, mostly because it has great review, and since you have a few extra days, this will be a perfect time for you to go over and review those other topics. Alright, we'll see you soon.